In this week number 6, we are finally now going over the HTML, the CSS and the browser history, and we want to take a look what HTML, CSS actually stand for, where those two languages come from and how they have evolved, and who is actually nowadays in charge of releasing the HTML and the CSS code, and do the browsers need to support that code if they want to. So these are the questions that we want to have answered in this week. And before I go now into a more detailed structural overview of this week, let me do a brief review of what we have done so far. In week number 2, we got started with HTML code and CSS code, and we have gotten familiar with that code, with the syntax, how the code looks like. And we have also gotten familiar with the structural elements that are out there that we always need inside our HTML file in order for it to be considered valid. Then we have continued working with the div and the span element. The only two elements that we used, our rather focus was on CSS. In that language we always select our content, our elements, and then we give our content, our elements, its appearance in terms of what dimensions these elements shall have, how they shall be positioned, and how they shall look stylistically. And week number 3, the focus was on dimensions. So how much space an element takes up on the website. This is what is determined by all these properties, which is better known under the topic of the box modal. And then we continued with the display property, and the only things that we know so far is we can determine with that property whether things shall be on an inline level or on a block level. Meaning when they are on an inline level, then they can be next to each other. And once they are on an inline level, then they can make use of all these properties right here, the ones that we have gone over in week number 4. As well as the overflow property. Here we determine what we can do when text is greater, or when content in general is greater than the box itself, then it overflows, and there are a couple of very useful cases when we want that to happen. And then finally last week we went away from dimensions and positioning, rather we then concentrated on styling. In more detail we concentrated on text styling and went over all the properties that ultimately are in charge of how our text appears on our website stylistically. And the second part of last week, then we continued with further HTML besides the div and the span element, even though we can achieve all of the elements, what the other elements do in terms of appearance, we can achieve that all with the div and the span, but the other elements here have meaning, and we should always give our content meaning, as we have seen, because there are two other major parties that read our code that are reliant upon our code having meaning. One party are screen readers that are used by sight disabled people, and those screen readers, they tell the sight disabled person in form of a voice what is on that website at that given moment, where that person right at the moment is. And the person can then also use shortcuts to jump around to other areas on the website, but that only works when our content has meaning. Another major party are search engine robots, and search engine robots, they are used by search engines. They go around from website to website, read the content, and then they know what that content is about, and the more meaning our content has, the better they can judge what this page is about, and the better therefore they can rank our page in the search engine results. So these parties altogether ultimately read our HTML code. These parties altogether are better known under the topic of user agents, because all of them ultimately provide a service to the user. They are an agent to the user. And instead of them reading our code, the actual word is they are parsing our HTML code. So all of these three parties, they are softwares. And an HTML parser is also a software that is built into each of these three softwares. It's a sub-software then. So HTML parser is able to read HTML code, to parse HTML code. So this is from the previous weeks, and now let's go into the actual week on history. In the first part of this week we will be going over the HTML history and how we have gotten to the latest version of HTML5. We have gone over all these steps here. These are all L languages, and the M stands for markup. Same in HTML, markup language. Because what we are always doing inside our HTML file, if we wouldn't use those elements, then all we had on our website was text, nothing else, and the browser would display that text line by line. So what we achieve by using these elements, we ultimately achieve structure and appearance ultimately, and we can then select these elements. So we are marking up our content. So this is what elements do. They mark up the content, and therefore HTML is a markup language. And the HT stands for hypertext, because that's the main feature of the web, or one of the main feature. We are jumping around, clicking on text, jumping somewhere else, hypertext, markup language. And the latest version is HTML5, and here we will go over the history, how we have gotten to the latest version. Most of them are not used nowadays anymore, those other languages. The only ones that are is XML and HTML5, which is our language for the web. And then in the second section of this week, we will focus on CSS and that history. And that will tell us that by looking at that history, we will understand what cascading is. And that is very important for us to understand. It's the C in CSS. Cascading, style sheets make sense. It's the appearance for our content. Style sheets, the sheet, the file. And we have touched on cascading a little bit last week already. We have taken a look at the browser default style sheet. We have seen that the browser is using its own style sheet in order to give elements its default appearance, such as, for example, the H1 element is by default display block. It has a greater font size, a font weight of bold, and it also has a margin on top and bottom. And this is how it gives our elements its default appearance, the appearance that will be applied if we don't specify anything else in our style sheet. So we also have our own style sheet, and here we can override what the browser uses as default. And that is part of cascading already. The topic, or the actual one sentence, what cascading is figuring out what CSS rule to apply. That's cascading, and that can be broken up into further details. That is what we will be discussing in the second section of this week. And then finally in this week, section number 3, we will concentrate on who is actually in charge of releasing that HTML and the CSS code nowadays. And is there new code coming out, even maybe tomorrow or in the future? So this is what we want to know in week number 3, in section number 3, and we will also take a look whether the browsers, which are partly owned by very large corporations, do they need to support that code that is being released? And 3 things that we have to focus on in this week is that are relevant to us in this section, that are relevant to us is, first of all, sometimes it occurs that an element or a property is not supported by a certain browser. Such as, for example, the main element, as we have seen last week, it's not supported by Internet Explorer, only by the Edge browser, which is the latest version of Internet Explorer. So there, it's occasionally, only at a few occasions, it happens that an element is not really supported. In the past, it used to be worse. It used to be much worse, actually. So we are coming at a good time, pretty much, to be a web developer, because we don't have to worry about this anymore. There are only really a few occasions where we encounter an element or a property that is not supported by a browser. Then the second thing that we need to pay attention to is that sometimes properties or elements are new. They get released and they may still be in testing phase, such as the user select property that we have looked at last week. And whenever something is in testing phase, we need to prefix it with the according browser prefix that I'm going over once again in this week. So that's the second thing. Either it's not supported or it's in testing phase. And sometimes it happens that there are appearance differences, which we have also encountered last week concerning our Internet Explorer, which changes the baseline where the text sits once we make use of super or subscript, such as when we use square meters or H2O, as we have seen last week. So then the baseline changes, and this week is not, the main text is not in the center anymore. Instead, the subscript, the 2, is in the center. But this only occurs in Internet Explorer, and there are easy remedies for it. So here in Firefox and in other browsers it's all fine, and we will see there's little to worry about for us because there are easy fixes. So let's get started with our first section, HTML, the history right there, and how we have gotten to the latest version, HTML5. We have seen this diagram here already in week number 1. Tim Berners-Lee invented the web in 1989. And for him to invent the World Wide Web, he required 3 pre-inventions that already had to be out there in order for him to invent the World Wide Web. And 2 of them we have already discussed, one of which is the Internet, which is the communication between computers using the infrastructure that is out there, either publicly or privately owned, such as cables and wireless infrastructure, etc. And hypertext is the idea of jumping around, clicking on text, jumping somewhere else. So these pre-inventions had to be there already. Internet came out in the 70s, the first products of hypertext in the 60s. And we know nowadays with the web what we are doing is we are communicating with computers, but with specific computers. One part of computers have browsers installed. They need the content in order to display it inside the browser window. And the other computer half is our web servers. They have the content that the browser needs in order to display it inside the browser window. So when we enter an address or click a link, we are contacting a web server. Hey, give me the content. Content comes back. And then our browser displays that content inside the browser window. And then maybe there is a link to a complete different website or to the same website. Then we are contacting him again. If it's to a different website, then we are contacting a different web server. Hey, give me the content. Content comes back. And then our web browser displays that content. So it's a mix of the internet and of hypertext. Now that content that does come back, the first content that always is coming back, as we have discussed, is HTML, the content itself, the HTML file. And HTML is a markup language. Now the question is, did Tim Berners-Lee come up with the idea of a markup language? And this was not the case. There had to be a third pre-invention therefore out there. And that is a markup language called SGML, Standard Generalized Markup Language. So the idea of a markup language was already out there, the third pre-invention that had to be there, that Tim Berners-Lee made use of when he invented the web. And now let's take a look where SGML actually comes from, which HTML is based upon. At least the early versions of HTML, as we will see now in a minute. So already previous to the internet, previous to the 70s already, it was possible for computers to communicate with each other, but only when they were directly connected from point to point with a direct cable. So this was usually then the case when computers were in the same room, or at least in the same building at least. Then they could communicate with each other by a direct cable that connected them. So they could already share information such as documents with each other, already previous to the internet. And 3 people at IBM came up with the idea, now let's mark up our information that we exchange with each other so they can be displayed nicely on the screen, for example, or for example be printed nicely. So they came up with a markup language, a language such as those angle brackets, for example. So just a language, and of course then at the same time also a parser that is able to read that language. So it's kind of chicken and egg. Who was first? So one thing belongs to the other. So making up a language, a markup language, and then on the other hand you need of course a parser. One that is able to parse that markup language, make sense of it, and then act accordingly. And that language that they came up with, they named it, at least that's one meaning of it, is generalized markup language. And this was a good idea, so therefore things could be displayed nicely on the screen, but it's not only referring to the screen. For example, a parser, as we know, as we have discussed, a parser is just a sub-software. So it can also, for example, be built into a printing software. And then things, for example, can also be printed nicely. And it also has other use cases, as we will see in a moment. But this is now the first markup language, at least on computers, that was used, and it was a good idea, and other organizations or companies that were out there, that used computers already back in those days, which was the era previous to personal computers, so not really everybody had one, but other companies took that idea over. Good idea, we can also already share information with each other, because our computers are also connected point to point, and our information that we share shall also be nicely displayed on the screen and be printed nicely, for example. However, everybody was pretty much brewing its own beer, pretty much. So this company, IBM, was using its markup language and the according parser that could read that language. And then other companies were using their markup language and their parser that could read that language. And then the internet came along, meaning that not only could computers then communicate with each other in one building basically, but instead IBM, for example, could communicate then with the other organization. However, if they were using their own markup language and the according parser that read that language, and they were using their own language, then of course still things couldn't be displayed nicely on the screen or printed nicely, because everybody was doing its own thing. So therefore a call came up for a standard. And that is where standard generalized markup language came about then. So everybody should do the same thing. Therefore, since we can now communicate with each other, therefore we can all then display things nicely on the screen, irrespective who is sending the information. We are all using the same language, the markup language, and the same according parser that can read that language. So that was the idea behind that standard. Now it's really important to understand that a parser is not really only for displaying things on the screen. It can be built into a lot of softwares, in many softwares that want to make use of it. Therefore, I'm just using here a black box. So this is the parser that is able to read, for example, the markup language, such as this one. So it's coming in, of course it's coming in ones and zeros. So the angle bracket, once again, it's represented in, for example, in electric current off, and 4 times on, and then off. So that's the angle bracket. And ultimately that parser can make sense of it. That is what a parser does. The vocabulary, whether it's be in H1, is rather secondary. So for the screen, of course, it is important for a parser to understand that vocabulary, such as an H1, that it makes then things bolded, that it understands it's a headline. But SGML and also its successor, XML, both of them, they are not only used for displaying things on the screen or printing things nicely where that vocabulary is important to understand. Instead, they also have other meaning. Let me give you a meaning for XML, for example. XML is just the language that succeeded the SGML language, which is not used nowadays anymore. So I have a file on my computer, an XML file, which we can think of SGML is the same, had the same use cases. So I'm now selecting this XML file from my computer, and therefore I can also load it into an Excel file, as we see. An Excel file or Excel software also has an XML parser built in. So just for then displaying things. And here we go. This is now what I have loaded in. And now let me give you the code for it. And then let us investigate it a little bit closer. So this is right now the code, the markup language, XML, that I have loaded into my Excel sheet. And Excel can understand XML and therefore display things nicely here. And here we can see company name, contact title. So these are all the elements here that I have, the names. So I could have named them elephant, monkey, whatever I wanted. And that would ultimately be then here the title. So it's a loose language. There is no fixed vocabulary that SGML and also its successor XML used or uses. XML is still used nowadays. So it's a language without fixed vocabulary. Some parts had to be agreed up on fixed vocabulary, but only when things had to be displayed on the screen. Otherwise, it's completely as we want to have our vocabulary to be in those two languages. So that's the difference to the web, to a markup language on the web. Because on the web, all we use that markup language is ultimately, at least in the early days, to display things on the screen. And therefore, there had to be a fixed vocabulary. And because otherwise a loose vocabulary doesn't make sense on the web to use. So that's the difference between SGML and HTML. So SGML is the standard generalized markup language, and that was standardized in 1986. And HTML is drawn from SGML. So Tim Berners-Lee used SGML. It also recommended, or he also built a parser inside the browser, and a parser that can read SGML code, but with a fixed vocabulary. And that fixed vocabulary he recommended to be these 18 tags here, these 18 elements, all based on text in the early days. And most of them are still around nowadays. So for example, the anchor element, which is the link, so we click somewhere and then we jump somewhere else, the anchor. So that is HTML, and it's the language used on the web and therefore hypertext markup language. But it is SGML with fixed vocabulary, with those 18 elements. And SGML had a problem or an issue because it had loose rules. Meaning, for example, let me go back to that code here. If a person made an error when writing that code, for example, he left out the closing tag here, the end tag, then that would still be okay, because the parser, it was agreed upon in SGML that the parser would make up for those errors that the people made. And this is just one example. There are other examples. It was always the parser to make up for the errors. And there were several errors that the people could make. It was always the parser. And parser is just code, written in code. It's a software. And it was therefore quite difficult to build such a parser due to the fact that it always had to make up for the errors. It always had to somehow find out, according to the entire structure here, there must actually be a closing tag. So it would then add that automatically, that closing tag. So that was a problem with that language, because it was difficult to build such a parser due to the fact that it always had to make up for the errors. And this is why a language called XML came along, which is still SGML, but now the strict version of it. Now people could not make errors anymore. So for example, in this case, they had to use the closing tag here when they were done, when that tag was over. So they could not make errors anymore. So that is XML, the extensible markup language. It is still SGML, but the strict version of it. So now XHTML came along. So HTML, the people on the web also decided, that's a good idea, because it also will facilitate now us, all the browsers to build a parser, because it makes it much easier, because the parser doesn't have to make up for the errors anymore. So therefore HTML for a short period of time also decided to go for XML, the strict version of SGML, but named it XHTML because that's the version used on the web with a fixed vocabulary. And XHTML was then seen as too strict after the web evolved over the years. It was then decided, because it was too strict and other things, the web was static at the very beginning. It was only HTML and later also CSS. And it was static websites. And nowadays we know websites are completely dynamic. And many things can be added onto websites, external things, external applications, resources. And that strict version of HTML, the XHTML version, that prevented from the web further developing into a dynamic way, into that direction. So therefore people ultimately decided XML is too strict to be used on the web. SGML is too loose. It would make parsers. It would be too difficult to build parsers, but XML is too strict on the other hand as well. So let's go for HTML5. That shall be the own version now for the web. So its own parser. It's not based on SGML anymore. HTML5, the browsers are now using for that language its own parsing rules completely. And it's the best basically out of SGML and XML. And now the web can go in its own direction without always having to concentrate on SGML and to always comply with that language, with that parsing rules that language had. So HTML5 is now going into its own way, of course with a fixed vocabulary, as we know still. We are having seen our vocabulary of course, which one is the one that we are learning right now. So this is our CSS code vocabulary, and this is our HTML vocabulary. And HTML5 places also great emphasis on meaning, as we have seen last week, because the web shall be accessible to each and everyone. That is the reason behind the web, behind why Tim Berners-Lee invented the web, so everybody could have access to documents. Documents, in the early days, only text was displayed on the screen, nothing else. And the original idea behind the web from Tim Berners-Lee was to share documents and that everybody has access to documents. And therefore we are referring to our HTML file as HTML document, still up until today. And also why we use in JavaScript, which we have seen here, document, same for the same reason. So besides having meaning in HTML5, there's also a great emphasis of dividing up appearance from content. So everything should always be separate, appearance from content. So this is now HTML5, the latest version that we are now working with on the web, hypertext markup language version number 5, which got released in 2008, so not that long ago. Let's go into CSS, our second section now, and once we take a look at the history there, we will understand cascading, which is very important for us to understand as web developers. So in the early days, in the beginning there was no CSS. The only thing that existed was HTML, nothing else. Tim Berners-Lee recommended those 18 elements to be used. Hey, all browsers, whoever is gonna build a browser, make sure, or I recommend that your parser is able to read, to make sense of those 18 elements here. And those 18 elements, those HTML parsers that read those elements immediately applied the appearance to those elements. Meaning the web developers back in those days didn't have any control over how the website ultimately looks like. I mean, they could be sure that, for example, if they used an H1 element, which we have right here, a header element, they could be sure that the browser will ultimately make that one, for example, font size greater, but to what extent they will increase the font size, for example, they didn't have any control over at all. And that is just one example. And the user ultimately didn't have control over it either, how great the font size ultimately will be. And for example, if that person here is sight disabled and cannot read the regular text size, and back in the days, the zooming options were not really there. So therefore, this person couldn't use the web ultimately. That person would be excluded from using the web. And then, for example, this person is colorblind, and it cannot read certain text that's written on a certain color. So that person, if that website that he wanted to view was written on that color that he cannot see the text on, so that person was pretty much partly excluded from the web as well. So that was the idea then why cascading came along. Style sheets were known already before, in one form or another they existed, but the point of cascading came now along. People decided now let's not only give the web browser control of how the content looks like, of how the elements will appear ultimately. Let's also give the web developer control and also the user ultimately. All three parties shall have control over the content, how that content will appear on the website. And that is the first part of cascading now. So we are dealing nowadays with 3 different style sheets. First of all, we know the browser has its own style sheet, by which here it gives all elements its default appearance. And then it's us. We have our own style sheet as well. And we can always override the browser defaults. And the user, in actual fact, the user also has its own style sheet. So we are dealing with 3 style sheets from 3 different parties. Party number 1 is the user agent, the browser. Then we are considered to be the author. We have a style sheet and the user has one too. And we as authors, as web developers, we are always overwriting the browsers if we want to. And the user can, if he wants to, always override ours. So the user has the ultimate say. So this is cascading, finding out which rule is now being applied. Shall it be the rule from this party, or from this party, or from this party? But this is not all in cascading. Let's, for example, assume that we are overwriting the browser styles for the H1 element, or for a span element, for example. Now let's assume that the user doesn't specify anything. So meaning our style sheet, our party, ours will apply. We will rule in this case. And now the question becomes, sometimes it occurs that we not only have selecting the element once and give it its appearance, but maybe multiple times. Maybe we haven't encountered that now too much yet at this point, but it will come in the coming weeks, definitely. So I have therefore created a span element here, and I have wrapped it around this text by the person who wrote this child story here. So I want to give now this person here, or this text in general here, I want to give it now a background color. So therefore I have wrapped a span element around it, so I can select it with CSS. And now let me give it a background color. So I'm selecting that span element and I give it a background color of red. Now let's assume, now it doesn't make any sense now at this point, but let's assume that I'm using that exactly twice now, the same selection, and now I'm using the background color of green. So which rule will now apply? So there is more to cascading therefore. It's not just figuring out which party's style sheet will ultimately be taken, but also then from that party, which is ultimately will be chosen, then inside that party's style sheet, which rule will apply inside there as well. So we have known so far if the browser reads the same as we human beings read a book. So he starts from top left and finishes at bottom right. And therefore whatever comes later overrides what came previous. So therefore right now our span element, our text here, will be displayed in green and not in red. However, this is completely depending upon the selection here. It's called specificity now, this issue. How specific the selection is. So let's, for example, let me give now that span element a class. And let me name it QQ. And now let me select that element by its class. And QQ, and let me give it a background color of blue. Now this blue is now earlier than those ones. It's coming earlier. However, it will be applied as we will see. Let me just reload the page so it will be blue because the selection is more specific. There can be a lot of span elements on the page, but maybe only some of them share the exact same class. So therefore, this one is considered to be more specific, and the most specific one will always be applied. So that is therefore the specificity. And we can give that a point, a ranking system, so we can better have a touch for it, how this ranking is applied. So first of all, element type selectors. Like we have selected the span, we have selected the element by type. So whenever we do so, that is considered to receive 1 point. Whenever we select a class or a pseudo class, which we have also introduced already, then this is considered to have 10 points. And the one with most points, the most specific selection, the one that has most points, will ultimately be applied. And now let's go for an ID. And an ID, here we can see it even more clearly. An ID, of course, is very, very specific. An ID value can only be given to one single element. It's an identity, it must always be unique. Let me call it WW. And now let me select it by its ID, and of course this one will then be applied because an ID, that selection is very, very much specific. So let me give it a background color of yellow, and let us take a look how this is gonna appear. And of course the yellow will be applied because ID is most specific. It's considered to receive 100 points. And now comes the last one, which is inline styling. And inline styling is even considered to be more specific than an ID. Inline styling is that what we shouldn't do, because styling shall always be separate from HTML for the reasons that we have discussed. However, let me now do it to complete this ranking system. So here we just specify background inside the element itself in the same line with the element. That's why it's inline styling. And let me give it the background color of orange. And now let us view this one, and it's gonna be orange. So if we think about it, kind of ID only one element can have that ID, and only one element can have an inline styling. So it's kind of same specificity. but it's nevertheless, it's considered to be more specific inline styling. So that one is meant to receive 1,000 points. So this is the ranking system. Let us do 2 examples now. How many points would this one receive here? So what we have is, we have a type selector. So first of all, what is this selection here? We have introduced that one already. It's the child selector. Please give me all the divs that are children of the element with the class child container. So here we have a type selector, which is 1 point. And then we have all the children, and then we have a class selector. So a type and a class selector, and a class is 10 points. Therefore, in terms of points, this will receive 11 points. Now let's do one more example. How many points would that one get? So first of all, what we have here is, we want the first line of all div elements that are children of the element with the ID main container. And there is a pseudo element, and pseudo element is considered to be the same as the class, so 10 points. And then we have a type selector, which is 1 point, and then we have an ID selector, which is 100 points. So this is 111 points ultimately. So this is specificity, and now comes the last one that is part of cascading, and that is importance. Whenever we add an explanation mark and important to a value, then this one will be taken irrespective of how specific it is. So for example, from our selection that we have now made here, the last one that will be chosen is this one. Because this is a type selector, same as this one, but this one comes earlier than that one. So this would be the last one chosen from all the settings that we have now done here. However, now I'm adding important after it. And now let's take a look how it's going to be displayed, and it will be displayed in red. So importance overrides specificity. Importance will always be taken. We shouldn't, however, use it. And to be honest, I have used it already in JavaScript. It happened already. But it's true actually. It shouldn't be used. It should always be done in a way that we don't need to use that one. So an example when we can use it is to find out, for example, when something does not get applied and we don't know why, then we can quickly find out whether it is a cascading issue by just adding in important, because then we will see whether it's now getting applied or not. Of course, we can also inspect the element, which we will do in a second, to also find this out. But that is one opportunity, for example, when to use it. Another reason is this ranking that we have gone over here can actually be divided up into further detail, which in my opinion would just be further confusing. This is the actual ranking. We override the browser, user overrides us. What the user actually needs to do in order to override our styles is he always needs to add important. Otherwise, ours will actually prevail over the user styles that he specified. So that is another reason why important exists out there. And however, we shouldn't be using it, but it's part of cascading, so I have mentioned it. Part of cascading is therefore first finding out which style sheet from which party to use. Then inside that style sheet, which the specificity comes along. So then finding out inside that style sheet what rule to take. And also importance is relevant here, because that one can always override specificity. And that entire process is cascading, and to bring that into one sentence is just saying finding out which values to take ultimately, which CSS rule will be taken. That is cascading. And one more comment now is meaning we can of course create our own style sheets as well. We can create as many style sheets as we want. So what I have already done inside our file here, inside media, so there is always our CSS. This is how we have structured things here. I have created already a file, another CSS file, and I named it generic. So usually what we do in a generic file, or not usually, what we always do is put the general things in there. The ones that we always need for each and every website, or for most at least. Such as, for example, this setting here. We usually want all the elements to have box sizing, border box, which means include border and padding already in the width and height calculations, so we never need to reset things anymore. And this is what we, for example, could put inside a generic CSS file. And there are many other examples what we can put in here, which we touch on in the coming weeks, on the way as we go. Let me leave it here with this example. So it's very useful to have a generic file. Here are the styles that we pretty much use on all the websites, the settings that we always use. Now we have two options in order to now include this file. One option would be the regular one, which by using the head element right here, just by using another link element, and then here change the name, of course, the path, of course, and now we are including the generic file. So this one is one option. Another option that we have is we can include it straight away inside the Excel sheet, inside the CSS file. And whenever we include something, what do we do? What do we use? Always the @ symbol. And here the keyword here is import, and then inside two quotation marks we specify the path. And the path right now we are inside styles and it's in the same folder, so all we need to do is copy and paste that file here, .css, and that's it. Now there is one problem, or not problem, we have one thing that we should pay attention to. First of all is important, whenever we do this variation, whenever we go for that version here, then CSS files cannot be downloaded concurrently, simultaneously at the same time. We know from an index from a HTML, when the browser starts reading, then it encounters a link element, and href attributes are always those ones used to include something, same as source. And the difference is between href and source is href, whenever the browser encounters here a path, it starts downloading, but it continues on reading. And therefore it can download that one simultaneously. In comparison to source, here it always waits until the image in this case arrives. So here it can download things simultaneously, while with the import it cannot. So here it needs to wait until the things arrive, it has read the things, and then it continues on. So this is what we need to pay attention to, but ultimately it doesn't matter. Because we will not be, there are some other use cases when import is relevant, but ultimately we will put at the end everything in one single CSS file and even compress it later on. Like compression, we can compress images as well, as we may know probably. So that is what we ultimately will be doing, because we have to think the browser starts reading and then it encounters a path to the server. So it needs to go to the server again, and here it needs to go to the server again. And to reduce the server requests, how often the browser needs to send a request to the server, meaning that is time, just time that we don't have on the web. We always want our website to be displayed as fast as possible. So ultimately we will be putting everything in one CSS file ultimately anyhow. So it doesn't matter, we can go for both options for now. So just that we have heard what the shortcomings of each options are, of each option is. These options we have, but ultimately everything will be put into one single CSS file anyhow. So this is the last comment now on specificity. Actually one more comment. Let us now inspect our element here inside our inspector. So here we have the option to always find out also not only the box model that we have introduced already, but also the rules are here. So here's this element that I have now selected, and here we can view what rules are set on that element and what rule is ultimately being applied. So here it's always according to specificity. Inline is listed first, that's 1000 points, and we can see that one is crossed out, that one is not being used. Then comes ID, 100 points, it's crossed out as well. And then comes class, it's 10 points, it's crossed out as well. And then comes that span element, and that one is not used either. Instead, that one is used because we have added important to that one, which will override everything else. So here we can see what is ultimately being applied. Now we may be wondering, why are there so many values right here? And that is part of next week, because background is actually a shortcut for multiple things at the same time. And the first value in that shortcut is just the color. So we can use that shortcut just to define the color as well. And these other values are then inserted, the default values are then used. Or the initial values, which we are going over in a second now. So just that we don't wander here right now. So let's go further into CSS. There is one more thing to discuss, and that is the computed value. We have discussed that there is a value given ultimately to an element, a value given to a property for an element. So elements always have these properties applied, and there is a value set for any property has a value ultimately. And this is what we find out now, what we want to find out now, the difference between browser defaults and initial value. And that is ultimately the computed value that we want to reach to, which is a step coming towards all these other values. So first of all, we have the declared value. The declared value are the values declared by the browser, by us, and by the user. So these are just the declared values. And the cascaded value, of course, is then the one that will be taken, that wins the cascading process from the three different parties, style sheets, then from specificity and from importance. And then comes the specified value, because sometimes there is no cascaded value. Let's, for example, that the user agent, the browser, the user, and we didn't specify anything. So maybe there is yet not a value, maybe cascaded value doesn't exist. So the specified value is either the cascaded value, and if there is no cascaded value, then it might be inherited. So then the specified value might be the inherited value, not the cascaded one, because that one doesn't exist. None of us did specify anything, so it might be the inherited value. And if there is no inherited value, then the browsers are supposed to take the initial value. And that is now the initial value are the values that are set to be used by the organization that is behind the web that we are discussing in a moment. And here are this organization defines how the browsers ultimately shall be built, the HTML parsers and the CSS parsers. And here are the initial values to each and any property. And if there is ultimately no cascaded value and also no inherited value, then the browser shall fall back to the initial value. Then those values here that are listed here shall ultimately be used. So this is the difference between the browser, the default values, and initial. Because the browser doesn't apply a value to each and every property, only a couple of them, so as he wants to. And the initial values are the ones that are determined by the organization behind the web. If there is no value, then fall back to the initial ones. So ultimately, nevertheless, it's the value that the browser uses, so we can think of the browser value. So it's similar almost, it's not the same as the default, but it's the browser value that the browser ultimately uses. So right here at this point, we definitely have a value. It might be the cascaded value or the inherited one. If not, it's the initial one. So at this point, there is a value for each and every property. And then comes the computed value, which is the last one. Maybe there are values that are in percentages. For example, a width or a height is defined in percentage. So ultimately, the computed one is turning percentages into pixels. and then the auto value might ultimately also must be turned into pixels. And that is actually done in further steps right here. There, it can be divided up in two other steps, but which I find rather confusing or not too important to consider now. Therefore, let us stop with the computed value. The only relevant value that I consider relevant to us, because we can always use the inspector, and here is the computed, that we know what that actually means. And here are ultimately, first of all the values to the properties that we have specified. And here also again all the background properties, because we use the shortcut background, and therefore these are applied, all of them here. And here we can include the browser ones. And here are all the values to each and every property that is ultimately applied to this single span element here. Here we can find that out under that tab. So here are always the rules. Here we can find out the computed values. Then box model we are already familiar with. Animations we are getting to quite later in week number 15, I believe. And here are the fonts also. So we can always find out what font is something having. So we are pretty much through all of these tabs right now here under Inspector. Now this is the main category under which these tabs are inside. And these other categories we will discuss in the future. So let us now go to our final topic, and that is the browser. The browser history. Sorry, one more comment to CSS. CSS is usually referred to as CSS 3, just referring to the latest version of CSS. And CSS 3 doesn't really exist. because CSS is such a difficult language, and it was so difficult to get an agreement in which direction each section of CSS shall go. Therefore, people decided to divide CSS up into many parts, into many so-called modules. And some of the modules are in stage number 4, some are in 3, some are in 2, and some are in 1. So there is no real CSS 3. However, CSS 3 is used just as a common expression to refer to the latest version of CSS. So now, let's go into the browser. So that was the last comment on CSS. And first of all, in the browser, we want to find out who is actually in charge of releasing the HTML and the CSS code nowadays. And then do the browsers need to support that vocabulary, for example, that is being released, the vocabulary for HTML and CSS. Now the first HTML version was released by Tim Berners-Lee, as we know. So Tim Berners-Lee was recommending the browsers, hey, all browsers whoever is building a browser out there, that is will then be commercially used or be used by ultimate users. If you build a browser, I recommend you to make sure that your HTML parser that you build inside it can read those 18 elements. So this was so Tim Berners-Lee recommended the first vocabulary to be used. However, then things started to diverge, and that is the reason that ultimately an organization was founded. So let me use these two browsers, these two early browsers that were out there as an example. Even though there have been other browsers out there, but let me only do this example to show you how things diverged by using those two browsers. So the Viola browser and the Mosaic browser. And for example, the Mosaic browser and the Viola browser, they both of their HTML parsers could read those 18 elements, those 18 tags here. However, for example, the Mosaic browser extended it by the image element, and another browser extended it in that way, and another in that way. So ultimately things started to go into different directions, and the original idea behind the web for equal access was threatened therefore. And meaning that web developers, if they build a website according to what that browser supported in form of vocabulary, then if a user ultimately used the Viola browser, however, then some elements, some tags could not be displayed there, which was of course bad. So things started to go into different directions here, and therefore Tim Berners-Lee decided to call for an organization, to found an organization called W3C, World Wide Web Consortium, and all the members, all the industry who are part in the web, or meaning all the browser companies and anybody else, any tech company that is part in the web or the internet, is a member at the W3C. And all these members together ultimately nowadays decide which direction the web is going in terms of, for example, also vocabulary, HTML elements and CSS properties. And where there are a lot of members, things take a while until they become a standard. So these are all the steps that these members go through, and ultimately there will be a voting. And if there is a majority voting for that direction, for that vocabulary, for example, for those elements that shall be introduced, then ultimately that will become a standard, a W3C recommendation. And everybody, the entire members, including all the browser companies that are members here, they are ultimately supposed to follow these standards. And we will now find out that this didn't work out as it was hoped for to work out by having this organization and by letting everybody together decide on those standards. So first of all, let me get rid of the Viola browser, because the Mosaic browser is the relevant one in the early days. It is attributed with having caused the World Wide Web to boom, to get started, to launch off pretty much. And in terms of timeline, so we are speaking about 94, when that took place. That's the era of the Mosaic browser when things started to take off. This is in terms of how many websites are accessible out there in those days. And in terms of users, so in those days, something like 20 to 40 million users. And then things started to increase then from that point onwards. Now, Mosaic decided to make money by licensing their browser code. So browser is just a software, it's just code. And they decided to allow a company called Spyglass to license, so they licensed that code to Spyglass and allowed them even to further license that browser code. Of course, then Mosaic would ultimately get a financial share of it. Then an investor saw the opportunities that the web had, and it contacted the Mosaic head developer, who is in charge of the head developer in charge of building the Mosaic browser. And he said to him, hey, let's go into the market huge. There are big opportunities. Let's go for our own browser and go big into the market. I have the money. You have the expertise. Let's go. And they together built the browser Netscape. And even further employees from the Mosaic browser ultimately ended up at the Netscape browser. What they of course had to do, they had to modify that code a little bit in order that they did not have to face any lawsuit. But ultimately Netscape overtook the market and reached something like 90% of the market very soon, in the years to come something like 96. And also who came along in 95 is Internet Explorer. And Internet Explorer is the one that belongs to Microsoft. So Microsoft, who was already in the industry with its operating system Windows, also saw the opportunities that existed by having a browser in the market. So they also decided to enter the market. However, they didn't want to start writing that code from scratch from the beginning in order to build the browser. So what they did, they contacted Spyglass and said, hey, you are allowed to further license the Mosaic code, so can we please have it for a certain financial amount? And this is how Internet Explorer version number 1 came along. It's completely based on the Mosaic browser, and Netscape is based on the Mosaic browser as well. So both of them are coming from the Mosaic browser actually. Who also came along in 96 is Opera, which didn't have a significant market role back in those days. Nowadays, however, it's one of the major browsers that we need to consider. Here are the 5 major desktop browsers for us that are relevant to us as web developers. And here are the 4 mobile browsers that we need to consider as well as web developers. But the Mosaic and Spyglass didn't play a role anymore pretty soon after, so we can get rid of those. It was pretty much all about Explorer and Netscape. This is better known under the browser war number 1, on which there are many documentaries and reports out there on the web. And what happened ultimately is that Microsoft had a huge advantage because they had the operating system Windows, and the personal computer time was still booming. It was still in a booming phase. And what happened is that they bundled their operating system Windows with Internet Explorer ultimately. And why would those people who ultimately purchased a Windows operating system who had Internet Explorer already installed, why would they go out and purchase Netscape? Because that was a purchasable browser. So Microsoft with its Internet Explorer had a huge advantage. And what they also did, they did other agreements with other resellers and also an agreement with Apple. They went to Apple and said, hey Apple, you don't have a marketable browser yet on your Apple machines. Take our Internet Explorer and make it the default browser on all Apple machines. So huge was then the advantage of Explorer over Netscape, because all Apple machines and all computers with a Windows operating system ultimately basically had the Explorer installed and were using the Explorer. So Netscape ultimately was kicked out of the market basically. They didn't have money anymore to pay its employees. So what they ultimately decided to do, they made the Netscape browser to be open source. And whenever something is open source, what that means is that the entire world can take a look at the browser and at the code of that software. And whoever is knowledgeable and has the expertise can, for free of course, it's rather a privileged thing, can then further develop that browser. So that is open source, and ultimately over a few steps, which I'm now skipping, what Netscape ultimately became is Firefox. And Firefox still until today is kind of a community browser with owned or behind there is an organization without really financial pursuit behind it. It's a community browser by the community for the community. And in terms of timelines, so we are speaking of the era 96, 97 of Netscape here, and then Internet Explorer pretty much took over. And the monopoly power for Internet Explorer lasted until 2004. This is where things started to decrease. So it's said to be 95% of market share that Internet Explorer had in the year 2004. That was its peak at that time. So this is in terms of how many websites existed out there. And we can see here, even though that was the peak, there is still a lot of market share to be distributed. And even today, even further today. So here we have the number of users. So this was the era of Netscape right here. And then came the era of Explorer, who took over and had almost the entire market in 2004. So this is the number of users, something like 1 billion users at that time. And nowadays we are marching towards half of the population, something like 3.5 billion users out there. Now comes the fall of Internet Explorer. And there are a couple of reasons that are involved here. First of all, one reason is Safari came along. And Safari is the browser that is owned by Apple. And Apple had the agreement with with Microsoft to have the Explorer installed as default browser. But now, as soon as, of course, Apple had its own marketable browser, the Safari browser, then of course they didn't use the Explorer as default browser anymore. Instead, of course, they used their own browser, Safari. So that was one reason. Let me straight away bring Chrome in, which came along in 2008, so a little bit later actually. But now we are complete. Now we have all of our 5 major browsers here for desktop. These are the mobile ones. And another reason why Microsoft lost market share is because they didn't really follow the rules that the W3C recommended. So what they said, hey web developers, if you want to make websites, you need to follow our rules. And not the ones that are the standards actually, that everybody together agreed upon. We have monopoly power, you need to follow our rules. You need to make websites according to our code, what we recommend. And another reason is that Microsoft, due to its monopoly power, they started to neglect innovation. And the web was back in those days still static. So from plain HTML, CSS websites and a little bit of JavaScript. But however, it was still static and it was marching towards a dynamic way. So the web evolved over the years, of course. And while the other browser companies marched with those innovations, they continued to innovate in those directions. Microsoft missed that to certain extents. So another reason why Microsoft ultimately lost market share, because the users they ultimately found out that the websites inside Explorer don't look as good as they do inside other browsers. So they started to download other browsers, and those other browsers were for free then in those days. So another reason why other browsers had then more gained market share, because they were now for free. So there are several reasons involved here. And one point here is why we go over this history is because of that monopoly power that Microsoft had. Web developers had quite a difficult time, because what they always needed to do is to make a website according to the standards, like all the other browsers, which the other browsers to greatest extents followed. And then they had to remedy, if they wanted to also support Explorer, they had to pretty much make almost a complete different website. So it was much difficult for web developers to make websites in those days. And that's not only in those days, that actually lasted to just recent years, as we will see now, for the reason to come in right now. So Microsoft, of course, has its operating system, and any software always comes in versions, of course. So from Windows 1 until today, Windows 10, for example. And also, so do browsers come in versions such as Internet Explorer 1. And the latest version nowadays is the Edge browser, which was just released last year. Now, every browser usually that we know of updates automatically. And that is of course good. So if there are changes in the web, so other elements, for example, can be used, or other properties, then the newer versions, then they support it maybe. And then people have to wait a little bit until the older version dies out, that nobody uses them anymore. And then we can make use of those properties and elements that are new. And because browsers usually update automatically, or the vast majority update automatically, then those new elements and properties that are being released, they can be used straight away. So wonderful. However, now comes the problem with Microsoft, because they decided their market strategy was to bundle their operating system with the Internet Explorer, or the other way around actually. And therefore, there was a compatibility problem ultimately. Meaning those people who, for example, had Windows XP installed, and that was a very popular operating system, the latest version that was compatible, the latest Explorer version that was compatible with that operating system is Internet Explorer 8. Therefore, this was the latest version that people could upgrade to, that the upgrade happened automatically then to IE8, but not further. And IE8 is still a difficult browser, so is IE9, so still not following the standards, still a lot of elements and properties are not really supported in those two browsers. So that was the problem, so people got stuck, and because Windows XP was such a popular operating system, for example, also companies who used Windows XP, they built their own software that is only compatible with Windows XP. And they didn't want to put any more money in the software later on then, so therefore that was a barrier for them to upgrade to a later operating system. So therefore many people got stuck with Windows XP, and therefore also with the latest version that is available on Windows XP, the Internet Explorer 8. And the IE9 is the latest version, for example, for Windows Vista. So things got stuck because of that bundling, and therefore these versions who still have lack of support for many elements and properties, so web developers still had to remedy things over and over the time for quite a long time because of that fact that those just got stuck. They just are still around still until today. However, we are learning to be a web developer now, and we will not support those two browsers here anymore. Neither will we support IE10. We will start from IE11 onwards and the Edge browser. Because once we can really develop websites, then this era is gone or is almost gone. So that it's completely not worth it for us to go over the remedy solutions, how we can make the website at least approximately the same in those versions of Internet Explorer. XP was announced 3 weeks ago to be not supported anymore. If there should ever be now a security hole coming out that can be exploited by a hacker, for example, then those holes will not be filled by Microsoft anymore. This is kind of a reaction, now this is the last call. You should now go away from XP and upgrade to a later version. So it will soon be over IE8, the era of IE8 and 9 and 10 as well, because everybody upgrades to 11 usually. Some people don't upgrade to the Edge browser though, because you need Windows 10, and there are for several reasons, people don't want to upgrade to that browser. So therefore what we will be supporting in that course is IE11 onwards, but the other ones are not of interest to us. Therefore, we are coming really at a good time to be a web developer, because we do not have to deal with that mess anymore that existed in the earlier days. Sometimes it happens though, and we have encountered one example last week already, and that was the main element, which we then also found the remedy solution for. The main element is not supported by Internet Explorer 11 and earlier only by the Edge browser. So this is one thing that we sometimes need to consider, but rarely now, so not at a lot of occasions. One of which was the main element, and of course I will always mention it when we encounter such an issue. Another, then we can always find it under the details here where everything is described. So browser support, whenever I wrote here OK, so that judgment of OK is based on IE11 and later. So not earlier versions are not considered in that judgment here, whether they are supported. So this is all we will be supporting, IE11 and later. So that is one thing that we need to consider, whether things are supported by browsers, and we can always find that out by that website can I use. Here is for example the main element. So 8 doesn't support it at all, 9, 10, 11 do not support the main element. And this is referring to all these elements. So 8 doesn't support none of them here. And 9, 10, 11, at least they support all of them apart from the main, this one, that we found the remedy solution for last week. So on this website caniuse.com we can always find out the things, whether things are supported, and of course I will always mention it during this course whenever we encounter one element or property that is not supported by a certain browser, which is usually Internet Explorer, for the reasons that we have just discussed in the history. So now comes the second thing that we must pay attention to, and that is when a property or an element is new. So for example, or a property actually, because a properties must always then be prefixed. Because when an element is new, it's not in testing phase. HTML is a simple language, but CSS is rather a difficult one. So for example, user select, this one is a new property that's in testing phase still, and therefore we need to prefix them always. So in order that our website doesn't break in the future should there be any changes. For example, as mentioned last week, this is the actual property here, and this is the prefix. And the prefix, first of all, they are according to the browser engine. So Mozilla Firefox is using its own browser engine, Microsoft as well, MS for Microsoft, Mozilla, and WebKit is a browser engine that is used by Opera, by Apple, by Safari, and by Chrome, or at least a subversion of it, a subversion of that WebKit browser engine. So it's based on that diagram that we have seen last week, that it's not really the most difficult thing to build a software, a HTML parser and a CSS parser, but the difficult part inside the browser is getting ultimately the things onto the screen. That is in charge what the engine does. Very difficult, the core part of the browser. Getting the things onto the screen in the correct way. And that is based here on that WebKit. That engine is WebKit for the three mentioned browser, and here it's MS and mods. So this is what we need to pay attention to, because we need those prefixes should there ever be a change in the future. For example, they decide to change from user select, now a dumb example of course, to user selects ultimately. If they do that and the browser only understands user selects now from that point onwards, that means if we already have a website and use user select, the old version, then that doesn't work anymore. Therefore, we use prefixes, meaning the changes that are then done are not done on the prefixed version of that property, but on the actual version. And once the prefix can be neglected, then it's not in testing phase anymore, then we can actually completely use it without. So that is the second thing that we need to pay attention to. First is if a browser doesn't support things. Secondly, if things are in testing phase. And now comes thirdly, when there are different appearances. As for example, we have seen it right here. The browser displays our sub, or it aligns the text still, it aligns, positions the baseline still in a way that the regular text, not the superscript is in the middle, but the regular text. And this is not what Internet Explorer does. So Internet Explorer instead makes the baseline in a way that ultimately the superscript here is in the middle. So this can be easily remedied by another style sheet called Normalize CSS. Well, we can name it whatever, but this is what it does. And there are several Normalize CSS sheets already prepared, style sheets already out there that just normalize all the behavior that are different across browsers. And here are just CSS rules inside there that do these remedies already, so we don't need to worry about it. So I'm using as well one of those normalized sheets. However, I am not supporting IE8 already now either, so we can use this one. Doesn't matter which one we use, but this is what such a style sheet does. And here is an example how that one looks like. And here we can see here are the remedies for sub and sub in how then the baseline is positioned. So as soon as I now include this normalized style sheet, and I have included in here under my CSS folder, meaning I now have the options again either in here for the reasons we discussed, what we should do or why we should do things, or here, which I'm now doing, and include normalize right here. Normalize, and now here we see everything is fine again. Everything is remedied, everything is normalized across the browsers. It will be fine. So once we have a normalized style sheet, we don't need to worry about that third part anymore, whether there are differences across browsers in terms of appearance. So therefore we only need to worry about whether something is supported or whether something is in testing phase yet. So these are the two issues then that we need to still consider. Now this is it in terms of what we wanted to go over in this week. What I now want to do is I want to give you a couple of websites that are useful and then also give you a brief review of what we will be doing next week. So first of all, if we are not using that CSS file, if we don't want to use it, now this CSS file is of course a preference thing. So I prefer it to use because it can be used offline. We may have realized it already. It makes sense because we can make websites without having internet access. Because we are of course only communicating with our local web server, and that one is installed on our own computer. So we don't need to go out into the world somewhere. And of course we can only make websites once we either understand the entire code, or when we have questions, then such an Excel sheet, for example, would be useful, because then we still don't need internet access. And as long as those descriptions here make sense to us, then we can always find the explanation if we ever have a question, whether we want what attributes does that element have again, or what values does that property have again. So that is one solution. However, usually nevertheless we have internet access, so it's a preference thing. And the website I would recommend is the W3. So the actual website from the organization who is in charge, who consists of all these members, the browser companies, etc. So here are the most updated information always. On CSS, for example, it's always the wiki and then slash CSS or HTML. And here we find then the information, all the properties, all the selectors. So let me just click on properties here, for example. And then all the properties come up here. And then once we click on them comes the description then to each of these properties. So this is the website that I recommend to be using for if we ever have questions on values, properties, selectors or anything. Then the other one is Can I Use, of course, to find out whether there are cross-browser issues. And then the next one is Normalize, if we want that normalized style sheet. And another one is Stack Overflow. So should we ever have a question about anything about HTML, CSS, and any other language that we are coming across in the coming weeks, so then we can ask questions here. And here we can see, so this one got asked a minute ago, next one a minute ago. Many questions are asked here and answered pretty much within minutes. So we can always ask questions here. It's quite a popular website. I don't know of any alternative, but most likely there is maybe an alternative to this website. And what we should do, or what I would recommend at least, is that we can of course insert code here when we ask a question. So here is ask question. Of course we need to register here. And when we ask a question, then we can include the code right here, but the preferred way is to use a fiddle. And there are also several alternatives out there. This is the JS fiddle, JavaScript fiddle. And here it's kind of an online editor, where we can enter the code, here the HTML code, the CSS code, and here the JavaScript code. And as soon as we then hit run, then the results will be displayed right here. So let me just for a second take a little bit of code out here, only the header here that I have. And of course without the CSS now, let me do it without the CSS. And then this one will be displayed. So without CSS, things are not as nicely displayed. Now if I also included the CSS, it would look exactly the same as the header that we have here on the homepage. Without the images, of course, okay. But here it's much better for people to understand than what you actually mean. So it's much easier for you to ask the question as well. Just tell them, hey, look inside the link, there are the further details, just take a look there. So this is what I would recommend. So also, of course, we need to sign up at one of the options. There are several alternatives here, so whatever we would prefer. So now lastly, a quick overview, a quick review of next week. So what we will be doing next week is multimedia lecture number 1. We will be concentrating on images and videos, and again on positioning videos and images, multimedia. And we will also take a look at background images. We have seen the background is not only used for colors, determine a color, it's a shortcut for even other properties. So in terms of vocabulary, let me just go here. So here it's backgrounds and object fit. Those ones it's under positioning. However, background is still styling as well. So it's these properties we will go over next week. And in terms of HTML, it's gonna be those ones that we will go over, and also the image one. But it will only be multimedia week number 1, where we rather concentrate on positioning things. So the styling part, we have another multimedia week later on, so again on images, etc. So next week will rather be on positioning, so we have images and videos already on our page, because then afterwards we go over out of the flow positioning. So we can see this text here. It's of course just in a box. Everything on the web is a box, as we have now realized. Everything is a box. And even lines, text of lines are inside a line box. Span elements are considered to be text boxes. It's all about boxes. And we want to place other boxes on top of, for example, this video or on images. Such as, for example, also drop-downs. They are also on top of other things. Meaning they are on a different layer, ultimately. And therefore they are not affecting everything else that is on the website. The things that are in the flow, as we have discussed. Because things that are in the flow are always listed one after the other. So this box comes before now the main container, the yellow one, the main thing. The header comes before. Where the code is, this is where things listed. And everything then affects the things afterwards. For example, the navigation here comes after the header, because the header is occupying that area. So everything is in the flow and determines what the things that come after, where those things then will be, because that one is occupied here. And this changes once we go out of flow. We go onto a different layer then, bringing things on top. First of all, next week is multimedia lecture, multimedia week number 1, which is on video and image positioning.